So, exam for Algebra 2. I want to read this to you first. The performance final exams this Tuesday, and it's going to count for 5% of your overall grade. Then, and also it can't be retaken or replaced. In addition to counting for higher. So for each question, the mock that it replaces will be provided. So the first question we're going to go over is, or the first part we're going to go over is Mach 1 and then Mach 2. We won't do one for Mach 3 because we did our midterm for that one. And then the last two, Mach 4 and Mach 5. So if the score's higher on this than it was on one of those mocks, then this grade will replace that mock grade. So for the first part here, it says complex number operations Mach 1. So this is part 1. So it says simplify each complex expression. So on this first one, hopefully you see that these are imaginary numbers, complex numbers actually, that have imaginary parts to them. So what we want to do is we're going to combine like parts. But first, we're going to do the middle part because we have this 3i minus 6 plus 5i times 2 plus 7i minus 4 minus 2i. Okay, so I'm going to leave this in our I'm going to leave this first one in our parentheses for now, 3i minus 6. And then I'm going to multiply this part right here, 5i times 2, which would be 10i, and then 5i times 7i would be 35i squared. Now, hopefully you recall that this changes to a -1, so that's going to make this whole term a minus 35. All right, now let's keep going with the rest of ours. So now I'm going to multiply a -1 times all of that, so that's going to give me -4 plus 2i. Now what I'm going to do is I'm going to put all my like terms in sets of parentheses. So I'm going to take real parts, which are here and here and here. So that's going to give me -6 minus 35 minus 4. And then I'm going to add to it all my imaginary parts, which are my 3i, my 10i, and my 2i. So now all I'm doing is combining like parts, so we're going to get 45. When I combine all those, plus 15i. All right, so on the next one, we have to find the conjugate, right? So we have to find the conjugate. Hopefully you guys remember what a conjugate is. That's when we change the imaginary part of the denominator. So we're going to do 7 minus 3i over 2 minus 4i, and then we're going to multiply that by the conjugate down in the denominator. So that's going to be 2 plus 4i, and this is over 2 plus 4i. There we go. So we can use the box method, or we can use the distributive property. What I'm going to do is just do the box down here just to help you guys out. 7 and a minus 3i. I'm doing the numerator right now. 2 and 4i. Okay. So that's going to be 14 minus 6i. That's going to be 28i. And that's going to be minus 12i squared. Recalling again, the I squared becomes -1. Okay. So now that's going to be a positive 12. So we're going to get 14 plus 12. And then we've got our plus 28i minus 6i. So we're still working on our numerator here. So 14 plus 12, that's 26. And 28i minus 6i is 22i. Now that goes over our denominator. Now, if you recall, the shortcut that I taught my students was we square the first term and we square the second term and we add them together because we're going to square I, and that's going to be I squared. It's always going to change it to a positive, okay? So now let's go ahead and simplify this. It's going to be 26 plus 22i over, this is 4 and 16, so that's 20. Now notice all of this can be reduced, right, by 2. So this is going to be 13 over 10 plus 11 over 10i. And that's our final answer right there, okay? This was our final answer over here. I didn't circle it. So, all right. So on the next one, again, we could just do the box method. So I'm going to create a box, and I'm going to do the 5 minus I up here, and I'm going to do -12 and 10i here. So let's create a box here. So negative 12 times 5, that's 60. Sorry, negative 60. Then we got a negative 12 times negative I, so that's going to be 12i. Then we got 50 times I, or 5 times I, that's 50i. I was doing it in my head already. And then we've got negative I times 10, so that's going to be negative 10i squared. Recalling again that we're going to change this to a negative 1. So that's going to make that positive 10. So this is going to be negative 60 plus 10. And then we've got plus 50i plus 12i. Okay, so this is going to be negative 50 plus 62i. So part 2 says calculate. Explain if the answer is real, imaginary, and why. Okay, so on this first problem, we are going to break it up into pieces. Okay, so this is equal to, I'm going to do the square root of negative 1, and I'm going to factor this, the square root of 64. And then times the square root of 4, that's the perfect square factor of 12, and the square root of 3. So again, we're going to simplify this. So this is going to be 8i times 2 square root of 3. So our answer is going to be 16i square root of 3. Okay? So this is going to be imaginary, right? And it's going to be imaginary because the square root of negative 1 equals I. Okay? So the next one, I'm going to break it up into our coefficients and then our i's. Okay? So we're going to do 5 times 4. And then we're going to do that times, we'll do it this way, I to the 8 plus 15 minus 2. Okay? So that's going to give us 20. And then 8 plus 15 is 23 minus 2 is 21. So this is going to be times I to the 21st. Now, hopefully you remember how to do these. So what we're going to do is we're going to take this 21. Remember, our cycles of I go in fours. So we're going to divide 21 by 4, and that's going to give us 5.25. Okay, and then what we're interested in is this 25 cents, right? So that's 1/4, right? So 25 cents equals 1/4. So it's going to be I to the first. And if you remember, I to the first is I. Now, if you don't remember, I to the second, hopefully you remember that one, is negative 1. And then I to the third, and then I to the fourth. Y'all remember these? Okay. So remember, I to the third is just I to the first times I to the second, right? So that's going to be what? Negative I, and then I to the fourth is going to be I to the second times I to the second, so that's just positive 1. Okay? So in this one, our answer is going to be, because this right here is going to turn to what? Just an I to the first. So this is going to be 20 times I to the first, which is just 20i, right? So this one's 20i, and the reason is, it's imaginary, okay? Imaginary, if I could spell that would be great, guys. Why? Because I to the first in the cycles of I is equal to sorry, that was not very pretty, y'all. Is equal to just I, right? Okay, this last one. So again, we're going to do the same thing we did before. And remember, this is a negative 1 out front here. So I'm going to do a negative 1 times the square root of negative 1 times the square root of 4. I'm factoring that negative 20, y'all, times the square root of 5. That's going to be times, again, the square root of negative 1. And then that's going to be the square root of 16. So we're going to keep working this. Okay, I'll put this up here so it's out of the way. We have more room. So we got a negative 1 times I times 2 times the square root of 5 times another I times the square, sorry, that's 4, right? Y'all, square root of 16 is 4 times 4. Okay, so we're going to take this negative 1, I'm going to take the negative 1, the 2, and the 4, and I'm going to multiply those. So that's going to be negative 8, right? Then we've got our I times our I, so that's going to give us an I squared. And then we still have our square root of negative 5. Y'all see that? Okay. So hopefully everybody knows that negative I squared is negative 1, right? So this is going to become a negative 1. So that's going to make it negative 8 times negative 1 square root of 5, which would be negative 8 square root of 5, right? Sorry, positive 8 square root of 5. So this one's going to be 8 square root of 5, because a negative times a negative is a positive, right? Okay, so down here, this time this answer is real, isn't it? Because there is no I in the answer. So we're going to say because I squared equals negative 1 and negative 1 times negative 1 equals positive 1. Okay? All right, so let's go to part 3. So this one says, 2 students were given the same problem. Their work is shown in the table below. Who solved it correctly and why? Okay, so obviously the problem is 8 minus 3i squared. So that is 8 minus 3i times 8 minus 3i. Could use the box here, but I'm just going to use a distributive property. 8 times 8 is 64. 8 times negative 3 is negative 24i, and negative 24i, and then negative 3i times negative 3i is going to be plus 9i squared. So I'm going to work this problem, y'all. I'm always going to suggest you guys do that because it'll be easier for you to find the error, okay? So this is now going to be 64 minus 9, because that's 9 times negative 1, plus, no, sorry, minus 48, right? 48i. So that's going to give me 55 minus 48i. All right, now let's look at who did the problem how. So the person who got the same answer we did was student B. So it says who solved it incorrectly and why. Okay, so obviously student A solved it incorrectly, right? So that's our first part. We're going to say student A. And then why? Let's see if we can figure out the difference here. I see this right here. Y'all see this right here versus this right here? So student A solved the problem incorrectly. Why? Because they did not repeat what? The 8 minus 3i, okay? And they should have, why? Because 8 minus 3i squared equals 8 minus 3i times 8 minus 3i, right? So just make sure you give a pretty good explanation here of whatever's happening, okay? Explain it in mathematical terms. You know, if you got an I times an I somewhere, and maybe that's the error, then you say it's I squared, and I squared equals negative 1, and negative 1 times blah, blah, blah. Y'all got me? So just make sure when you guys are explaining this, you do a very good job. All right, so now we're going on to Mach 2. So this one just says solve for x. So the first thing I'm going to do with this problem is I'm going to divide everything by 2 because I see that it has a GCF of 2. So I'm going to put that 2 out there. It's going to give me x squared minus 14x minus 32 equals 0. Then I'm going to factor this. Okay? So when I factor this, it's going to give me, what are the factors of negative 32, y'all? Factors of negative 32 that add up to be negative 14. I've got an x and an x here. I'm going to leave that 2 out there. That's going to be minus 8. No, minus. Oh, wait. It's minus 16 plus 2, right? Minus 16 plus 2. Okay, and then we're going to set both of those equal to 0. So we're going to do 8 minus 16 equals 0. So x equals 16. And we're going to do x plus 2 equals 0. So x equals 2. So those are our 2 answers for that one. Let me double check. Yep. Sorry, negative 2, y'all. I'm subtracting the 2 from both sides. Okay. So then, with this next one, we're going to multiply a times c, so that's going to give us our 12, okay? And if you can do, I'm going to show you both methods, but you could use drop down or you can use bottoms up. They're essentially the same, but so I'm going to use drop down, so I'm going to put 3x here and 3x here, and I'm looking for the factors of 12 that add up to be 8. Okay, so are there any factors of 12 that add up to be 8? 6 and 2, yeah, plus 6 and plus 2. Okay, so now we're looking for GCF here. There is here, so this is going to be x plus 2, and this is going to be 3x plus 2. Remember, again, we're going to set these equal to 0, right? So we're going to set both of these equal to 0. So this is going to be x is equal to negative 2, and this is going to be, we're going to subtract that 2x. We're going to leave it like this, 3x minus 2, so x is equal to negative 2/3. So there's our 2 answers for this one. Now, if you want to use bottoms up, which is the other method that we taught, then you're just putting an x and an x in your set of parentheses, right? It'll still be plus 6 and plus 2, only this time you're going to divide by that leading coefficient. So you're going to divide by that 3 here and 3 here. This reduces to be x plus 2. This one does not, so we bring it up here. So it would be our 3x plus 2. And again, there's both methods. You can use whichever one you prefer. The end result is the same, though. Okay, so our last one over here, we're going to multiply x times x, that's x squared, and x times negative 8, that's negative 8x. We're going to move that 19 over by adding it. So now we're asking ourselves, are there any factors of 19 that add up to be negative 8? Well, the answer to that question is no. So we're going to have to use our quadratic formula. So I'm going to use b squared minus 4ac, that part underneath the radical first. So that's going to give me, and remember, this is a, this is b, and this is c, right? Y'all remember that? So we're going to do negative 8 squared minus 4 times 1 times 19. That's going to give me, what did I get here? So this is going to be 64 minus 76, so that's going to be equal to negative 12. And I'm going to go ahead and factor this right now, y'all, because that's what's going to go under that radical, okay? So that's going to be equal to the square root of negative 1 times square root of 4 times square root of 3, right? So that's going to give me 2i square root of 3. So now we're going to do our negative b plus or minus what we just did, right? B squared minus 4ac all over 2a, okay? So on this one, again, minus b, that's going to be minus a minus 8 plus or minus 2i square root of 3. We already simplified that, right? So that's going to be over 2 times 1. All right, so that's going to be 8 plus or minus 2i square root of 3 over 2. And this can be reduced more, right? Okay, so how many times does 2 go into 8? That's going to be 4. How many times 2 go into 2? That's going to be 1, right? So that's just going to be I square root of 3. So that's our answer right there, okay? All right, so the quadratic part 2, this one says, what is the type and number of solution that each quadratic equation has? Explain your reasoning. So we're going to use the b squared minus 4ac, which is the discriminant, right? Okay, that's what we're going to use. And if the discriminant is positive, it's 2 real solutions. If it's 0, it's 1 real solution. If it's negative, it's 2 imaginary solutions, right? Okay, so we got our A, our B, and our C. So we've got negative 16 squared minus 4 times 1 times 64. That's going to be equal to 256 minus 256. So that's going to be 0, y'all. So it's going to have 1 real solution because the discriminant is 0. So there is 1 real solution. Okay, so the next one, I'm going to actually move that 35 first. So I got a 3x squared plus 20x plus 35. So now we have our A, our B, and our C. Okay. So we're going to do 20 squared minus 4 times 3 times 35. That's going to equal 400 minus 420. So that gives us a negative 20, right? So this time it's going to have two imaginary solutions, right? Because it's negative. Okay. So again, the discriminant is negative. Sorry, y'all. So there are two imaginary solutions. Okay. So this last one, we're going to move everything to the left. So I'm going to do 5x squared minus 15x minus 21. Here again, we've got our A, our B, and our C. So we're going to go negative 15 squared minus 4 times 5 times negative 21. This is going to be 225 plus, and it's going to be plus because we're multiplying a negative times a negative, and that's going to be 420. So this is actually going to be a really big positive number, 645. So this is going to give us two real solutions because it's positive, right? So the discriminant here that's supposed to be an A, y'all, is positive. So there are two real solutions. Okay? All right, so this next one. Emma solved the following quadratic by using the quadratic formula. Her work is shown. Did Emma make an error? If so, identify, explain, and correct it. If not, explain why Emma is correct. Make sure to use math vocabulary. Okay, so first thing I'm going to do is I'm going to work the problem over here on the right, y'all, because that's the best way for me to see where the error is. So 3n minus 4n plus 9 minus 3. I'm going to go ahead and subtract that, y'all. So I move it to the left. So it's going to be 3n squared minus 4n plus 6 equals 0. So now I'm going to pull my A, B, and C. There's my A. There's my B. There's my C. Okay. So, and we're going to put it in the quadratic formula. So we're going to go negative minus a minus 4 plus or minus the square root of b squared. So that's going to be negative 4 squared minus 4 times 3 times 6, right? That's a 6 right there, y'all. Okay. So all over 2 times a, so that's 2 times 3, okay? So it's going to give me 4 plus or minus the square root of 16 minus 72 all over 6. Then we got 4 plus or minus, that's going to be negative, isn't it, y'all? Yeah. The square root of negative 56 over 6. Then let's go ahead and factor that square root of negative 56. So this is going to be 4 plus or minus the square root of negative 1. 56 is 4 times 14. Square root of 4 times square root of 14 all over 6. So that's going to be equal to 4 plus or minus 2i square root of 14 over 6. So can't we reduce this more? So this is going to be equal to 2 plus or minus. And look, the how I figured this out, guys, is look. If I reduce this, this would be a 3, this would be a 2, and this would be a 1, right? Okay. So it's going to be 2 plus or minus I square root of 14 over 3. Okay. So that looks like that's the answer that I got. So this time there are no errors. She solved it correctly, right? Okay. So show me all your work here so you can prove to me that that's true, if that's true. Okay. So on this next one, it says f of x divided by h of x, right? So we are going to calculate that. So I'm going to actually write this x to the fourth plus 8x squared minus 6, okay, divided by x minus 4. Okay, well, the first thing I notice is that this is what we're going to divide by. I can use synthetic division with, okay? So I'm going to go ahead and put a positive 4 out here. Now, I also want to check and make sure I have all my terms, and I notice that I don't have an x to the third, and I don't have an x to the first, right? So when I write this, I'm going to write 1, 0, 8, 0, and negative 6, okay? So remember, we're going to bring down this 1, and then we're going to multiply 4 times 1. Then we're going to add the 0 to 4. That's 4. We're going to multiply 4 times 4. That's 16. 16 plus 8 is 24. 4 times 24 is 96. 0 plus 96 is 96. 4 times 96 is 384. And then we're subtracting that from it, so we get 378. So our answer here is going to be, okay, so let's do this like I would normally do it. So I'm going to put this over our x minus 4, because that's going to be our remainder. We're going to put a plus there. That would be our constant, right? And then the next term would have an x here to the first. This would have an x to the second, and this would have an x to the third. Okay, so when we write our answer, it's going to be x to the third plus 4x squared plus 24x plus 96 plus 378 over, guess what, x minus 4. Boom. Okay, so the next one's multiplication. So I'm going to use the box. Okay, so I'm going to put my 2x to the third, a negative 11x squared, and a 5 over there. And then I'm going to do my x and my minus 4 here. See if I can create a box here to keep my multiplication organized. And then that'll help me also hopefully look for some like terms. So we got 2x to the third times x. That's going to be 2x to the fourth, right? Then we got negative 11x squared times x. That's going to be a negative 11x to the third. 5 times x is 5x. 2x to the third times negative 4 is going to be negative 8x to the third. Then we've got negative 11x squared times 4, so that's going to be 44, positive 44x squared. Then we've got 5 times negative 4, that's negative 20. Okay, so we're looking for some like terms here. And I only see one set of like terms right here and here. Everything else is unique. Okay, so this is going to be 2x to the fourth, and then we've got these two, so that's going to be minus 19x to the third plus 44x squared plus 5x minus 20, and that's our answer right there. All right, so the next one is just subtraction. Okay, so I'm going to look for g of x. So we've got 2x to the third minus 11x squared plus, I'm going to leave a space there, 5, because we don't have an x to the first. Y'all see that? Then we're going to subtract f of x this time. Okay, so what I'm going to do before I do this, I'm going to actually multiply all this by negative 1. Okay, so that's going to give me a negative x to the fourth. And then I don't have an x to the third, but I do have an x to the second. So that's going to be, so this would be negative, negative, positive. Y'all see that? That's going to be minus 8x squared, and then plus 6. Ooh, I didn't have an x to this first, did I? So that's going to give me negative x to the fourth plus 2x to the third minus 19x squared plus 11. Okay? Part 2 says Susan wants to build a rectangular garden in her backyard. The width of the garden is represented by the function w of x. The length is represented by the function L of x. How much fencing will she need to go around the garden? So that word around, y'all, is our key here. because that means we're looking for perimeter, okay? And perimeter, if you remember, is 2 times the length plus 2 times the width, okay? So we have the length and width, but we're going to have to multiply them by 2 to get, and the reason for this, if you guys remember, is because we have 2 widths and 2 lengths if it's a rectangular shape, okay? So I'm going to actually multiply 2 times 4x squared minus 6x plus 8, and I'm going to add to it 2 times x squared plus 4, okay? So that's what I'm going to do. So I'm going to actually move that over here once I do it. And I'm going to actually take this. Let's see if I can figure out a way to move this up, y'all. Yep, like that. And I'll erase that so you guys can see that that's where I'm getting my perimeter from. Okay. All right, so now 2 times 4, let's go ahead and do that. 8x squared minus 12x plus 16. And then I'm going to add to that my 2x squared plus what? 8. Yes. So then I get 10x squared minus 12x plus 24 is my answer. So, so what we need to do is explain this. So we're going to say to find perimeter, or you know what, let's explain why we are finding perimeter, okay? So we're going to say we find perimeter because she needs to go around the garden. Okay, and then we can explain how she did that. So we do perimeter equals 2 times length plus 2 times width. Then add like terms. That's how we solved it, right? Then we're going to find how much space will fit inside the garden. So that's an area problem, right? Because they're asking us space inside. So area is equal to length times width. So now we're just going to multiply our length times our width. So I'm going to do it like this. I'm going to do 4x squared minus 6x and 8. And I'm going to multiply that by, I'm going to use my box method, y'all, x squared and 4. Okay. So let's see if I can make this a box here with ultimately 6 terms that we are maybe are going to combine some. We'll see. So 4x times x squared would be 4x to the 4th. Negative 6x times x squared would be negative 6x to the 3rd. This would be 8x squared. Then we've got 16x squared. Negative 6x times 4 is negative 24x. And then 8 and 4 is 32. So let's see if we have any like terms here. We have an x to the 4th and x to the 3rd. I do see 2 x squared. Y'all see that right here and right here. So we are going to combine those. So our answer is going to be 4x to the 4th minus 6x to the 3rd. Then we're going to combine that 8x and that 16x squared. So that's going to give us 24x squared. Then we got minus 24x and plus 32. So that's our answer. So then again, let's explain why we found area. So we find area because she needs the space inside the garden. And now let's explain how we do that. So we multiply length times width and combine like terms. Okay? All right, the last one says, if Susan decides to change the width of the garden, that is 2x units more and 5 units less than the original width, how much fencing will she need to go around the garden? So this again means we're going to find perimeter, right? So 2 times the length times plus 2 times the width, okay? So, so we are, okay, let's look at the width. So the width was 4x squared minus 6x plus 8. So 4x squared minus 6x plus 8. And it says we're going to 2x units more, so we're going to go plus 2x here. And 5 units less minus 5. So this is going to be our new width, okay? So this is going to be 4x squared. What is that? Minus 4x plus 3, right? Now remember, we're going to go 2 times the length plus 2 times the width. Now we already did the 2 times the length, so let's go back up here and see if we can find that. That would be 2x squared plus 8 right here. Y'all see it right here? So I'm not going to do it again. I'm just going to pull it down. So 2 times the length would be our, but then we're going to actually have to multiply this by 2, right? So we got, what is that? 2x squared plus 8. So we got 2x squared plus 8 plus whatever that is, right? So I'm going to pull it over here so we have room on the bottom. So we're going to get 2x squared. And I'm going to do plus 8 here, and then we're going to do this. So that's going to give us 8x squared minus 8x plus 6, right? So that's going to give us 10x squared minus 8x plus 14. That's our new perimeter, okay? So, and on this one, we would... So we would say again, we found perimeter because she needed fencing around the garden, right? And we had to add 2x and subtract 5 from the original. Sorry about that, y'all. It's not letting me write over here. The original width, then multiply by 2 and add, and, oh boy, that should be an N, y'all. Can't write. Whoa, it's not letting me choose my eraser. There we go. And add like terms, right? Okay, there we go. So part 3 here says the volume of a rectangular solid is given by polynomial, and I'm going to put length times width times height because that's what volume is. The length of the solid is given by 2x, and the width is given by x minus, ooh, it's covered up. What was it? X minus 3, y'all. I don't know where that went, but somewhere. So what is the height of the solid? Explain the setup in the process. Okay, so what we're going to do first is we're going to multiply. I'm going to multiply the 2 dimensions I'm given, the width by the length, right? Or vice versa. Okay, so I'm going to do 2x times x minus 3. And that's going to give me 2x squared minus 6x, okay? Then, what we're going to do is then divide the width times the length into the polynomial. The polynomial's volume. And we're going to have to do that using long division. And the reason we're going to have to use long division because it has a leading coefficient and x is to the second power. That is how we find the height. Okay? And if this question is given to you on the test, then it's going to actually give you that equation, y'all. Not make you explain it without it. Okay, so this is Mach 5. This is the test we just took, and we're going to calculate these. So if you remember, when we're multiplying, we're just going to factor first. So we're going to do 5 times x plus 5 over x plus 5 and x minus 5, right? And that's times, again, we're going to factor this. What are the factors of 9 that add up to be 6? That would be x plus 3 and x plus 3. And then this is going to be 5 times, we're factoring that again, that's going to be x plus 3, right? So now we just mark through the common factors. So I got a 5 and a 5, I got an x plus 5 and an x plus 5, and x plus 3 and x plus 3. So what am I left with? I got x plus 3 over x minus 5, okay? And then part B, we're finding the common denominator here, remember, because we are adding, okay? So we're going to multiply this first one by the other denominator, x minus 5 over x minus 5. We're going to multiply this one by the x minus 2 over the x minus 2. So once we have our common denominator, then we're going to just work on the top. So then we get x squared minus 5x plus 3x minus 6 all over x minus 5, x minus 2. So now we're just working to get combine like terms. So we get x squared minus 2x minus 6 over x minus 5, x minus 2. So that's our answer there. That was our answer over there. All right, this last one again. So this time we're solving, right? Okay, so there's a couple ways we could solve here. We could give this a common denominator, but before I do that, I want to factor the numerator just to see if I can simplify something, okay? So let's go ahead and do this. What are the factors of 35 that add up to be -2? That would be -7 and plus 5, wouldn't it, y'all? So that's going to be over x plus 5, and that's equal to 15. So what we get is x minus 7 equals 15. We're going to add that 7 to both sides. So x is equal to 22. Now we need to check for our excluded value, so we're going to take this denominator right here, set it equal to 0. So x cannot equal -5, and x does not equal -5, so that is our answer. So on the next one, it says use the given functions f of x and g of x to answer 2a through d, okay? So on this one, we're going to divide. So we've got f of x, 7x minus 28 over 8x plus 32. And if it's saying division, I'm actually going to keep change flip, okay? So I'm going to keep the first one, change the sign to multiplication and flip. So I'm going to multiply, okay? And that's going to give me, and then we're going to flip it. So it's going to be x squared plus 13x plus 36 over 4x squared minus 16. So now what I'm going to do is 16x, y'all. Sorry. That should have an x there. So now we're going to factor. So this is going to be x plus 4. 7 times x plus 4. This is going to be 8. So not plus 4. Sorry. That should be a minus 4. X minus 4. Okay, this is going to be x plus 4 here. Times, let's go ahead and factor this one. So what are the factors of 36? Add up to be 13. That's going to be x plus 4 and x plus 9. 9 times 4 is 36. Yep. We're going to factor out a 4x down here, and that's going to give us x minus 4. Okay, so let's see what we can mark out now. Can't mark out that 7, but we can mark out the x minus 4. We can mark out the x plus 4. So it looks to me like we're left with 7 times x plus 9 over 8 times 4x, okay? So that's our answer for that one. Now the next one, over here on B, says simplify multiplication, right? Yep, so we're going to just multiply them this time. So I'm going to write my first term like we did before. I'm going to do 7x minus 28 over 8x plus 32. Well, the good thing is we've already factored this thing, so this should be easier, right? 4x squared minus 16x over x squared plus 13x plus 36, okay? So 7x plus 4, no, sorry, I did that again, y'all. X minus 4. This one's going to be 8 times x plus 4 times, we got 4x here, we got x minus 4. And then here we've got x plus 4 and x minus plus 9, right? Yeah. Well, I only see one thing that reduces, y'all. The 4 and the 8. So this 4 can reduce that 8 to 2. That's it, y'all. I don't see anything else that can reduce. Do you guys? So we get 7 over x minus 4, x minus 4, and then down here we've got 2 times x plus 4, x plus 4, x plus 9. That one's ugly, y'all. All right. So part C says, identify the x values that make g of x undefined for these. Okay, so that means we're going to take, let's look right here. We're going to take this and set it equal to 0. We're going to take this and set it equal to 0. We're going to take this and set it equal to 0. Okay? And then for the other one, the only other number is the 9. Okay? So for the first one, it would be x plus 4 equals 0, 4x equals 0, and x minus 4 equals 0. And then also, remember, this actually started in the denominator, so we kind of still have to do that. So it's going to be x plus 9 equals 0. So these are all the values that it could not be, right? So this is going to be x cannot equal negative 4. This one's going to be x cannot equal 0. This one's going to be x cannot equal 4. And this one's going to be x cannot equal negative 9. Okay? So those are all the values that we could not have in our denominator, right? Okay? So, the last one says explain the similarity difference between solving A and B. So, I would say when solving, that was an M, y'all. When solving division, we keep the first term, change the sign to multiplication. Then factor both numerator and denominator, and cancel factors that are repeated. Okay? And simplify. All right, that's what you need to do. I'm so excited, y'all. I'm on the last problem. Okay, so at least you guys will only have to do one of these, right? Not all four of them. So it says Owen was given the following problem to solve. His work is shown below. Did he solve the problem correctly? If not, identify and explain the error he made. If so, explain why Owen is correct. Make sure to use math vocabulary. Okay, so here on this one, I'm going to work the problem over here on the right, guys. I like to do that because it helps me see where the error is. So 9 minus 4x over, I'm going to go ahead and factor this. So this is going to be x plus 6x minus 5, right? And then I'm going to subtract from it 2 over the x minus 5, okay? So I went ahead and factored it, so I kind of skipped to step 2, right? So what we're going to do is we're going to go ahead and multiply this by what? X plus 6 over x plus 6. So that's going to give us 9 minus 4x minus 2x minus 12, right? Because remember, we're multiplying that negative by both terms, okay? And then all of that is over our, and the way they're keeping it, we're just going to keep it that way. X plus 6, x minus 5, x plus 6, x minus 5. So then we're just combining our like terms on the top, right? So we've got our 9 minus 12. That's going to give us, what? Negative 3. And then we've got our like terms here, negative 4 and negative 2x. So this could be negative 6x all over x. I'm going to write it the way they have it, x minus 5, x plus 6, okay? So, yes, I definitely see that they didn't get the same thing I got. So, did he solve the problem correctly? No. And then we got to say what they did wrong. So, it looks to me, okay, you guys see this right here? So, what I see is different is this right here. Y'all see that? So, it looks to me, Owen did not multiply negative 2x by 6, comma, he multiplied 2x by 6. Thus, when he combined like terms, he added negative 4x and 12. No, sorry, not negative 4x. My bad, y'all. Not negative 4x. It was negative. It was 9. He added 9 plus 12 instead of 9 minus 12. Period.